Hello everybody, in this video we are going to solve problem number 5.48 from Fundamentals of Electric Circuits by Alexander and Sadiku 6th edition. So this is a differential amplifier and this is driven by a bridge. We are asked to find out this V0. Okay, so here this bridge is supplied with this voltage source of 15.5 millivolts. So only single voltage source is given, but we need to have two different supplies at these nodes, that is this will be one node and this will be another node which will be acting as the voltage sources for this differential amplifier. So let's name this as 1 and 2, and the first step is to find out the voltages at these nodes. So for these nodes we can apply KCL. It is Kirchhoff's current law. It states that in a particular node sigma in is equal to sigma I leave. Summation of the entering current is equal to summation of the leaving current. So we have to mark the currents. Okay, let's name this as I1 current, this would be I2 current, and this would be I3 current. This is I4 and this is I5 and this is I6. So for this first node, entering current is I1 current, that is equal to summation of the leaving currents, that is I2 and I3. So in this we can apply Ohm's law. So it is the potential difference divided by resistance, isn't it? So potential difference for this I1 is, it starts at this point and it enters into this node, right? So the potential difference here is 15.5 millivolts, that is 10 power minus 3, minus this V1 that is not known to us, which is to be found out by us, divided by this 10 kilo ohm. Okay, so that is equal to I2. I2 can be written as V1 minus this ground node, right? It is entering into this ground, that means zero potential, divided by that 30 kilo ohm, isn't it? So it is V1 minus 0, V1 minus 0 divided by that resistance values 30 into 10 power 3 kilo ohm, isn't it? Plus I3 is V1 minus, so it is entering into another node, and so we need to mark this node also. Let it be A and this one be B. So we can write it as V1 minus VA divided by the resistance value is 20 kilo ohm. So in this 10 power 3, 10 power 3, 10 power 3, we can cancel out. Similarly, this 10. Okay. So you can write this as 15.5 into 10 power minus 3 minus V1, that is equal to V1 by 3 plus V1 by 2 minus VA by 2. So if you take common denominator here, it is 6. So it is 2V1 plus 3V1 minus 3VA. 15.5 into 10 power minus 3 minus V1. So we need to cross multiply. It is 93.18 into 10 power minus 3 minus 6V1. That is equal to, here we have 5V1 minus 3VA. So rearranging the terms, bringing this minus 6V1 to the right hand side, so that you will get this as 11V1 minus 3VA, that is equal to 93.18 into 10 power minus 3. So we can mark this as first equation. Now we are going to apply KCL at node 2. So what are the entering current here for node 2? It is I4 is entering, and the leaving current summation is I5 and I6. For I4, I5, I6 we can apply Ohm's law, potential difference divided by the resistance value. So it is 15.5 into 10 power minus 3, that is millivolts, right? Minus this V2 potential divided by that 40 kilo ohm, 40 into 10 power 3, that is equal to I5. I5 is V2 minus that ground potential, that is 0, divided by 60 kilo ohm. So 60 into 10 power 3. I6 then. I6 is V2 minus VB divided by 20 kilo ohm. So kilo ohm, 10 power 3, 10 power 3, everywhere get cancelled. Then you can divide everything by 20. So here you get it as 3, here it is 2 times. Okay. So it is 15.5 into 10 power minus 3 minus V2 divided by 2, that is equal to, when you take common denominator as 3 here, it is V2 plus 3V2 minus 3VB. So cross multiply this things, then you'll get this as 3 times 15.5 into 10 power minus 3 minus V2. And here it is 2 times this 4V2 minus 3VB. So this is 46.5 into 10 power minus 3 when you multiply this term by 3 minus 3V2, that is equal to 8V2 minus 6VB. So rearranging the terms, we'll get this as 11V2 minus 6VB, that is equal to 46.5 into 10 power minus 3. So this can be taken as second equation. For the ideal op-amp, the difference voltage Vd is equal to 0 between these terminals A and B. As Vd is equal to 0 for ideal op-amp, that implies Va is equal to Vb. Both should be equal. Then only you will get the difference as 0. So using voltage divider rule, we can find out this Vb in terms of this V2. So what is Vb? Vb is equal to the potential V2 multiplied by this resistance 80 kilo ohm divided by the total resistance 20 plus 80 into 10 power 3. So this is equal to V2 into 80 to 10 power 3 divided by 100 to 10 power 3. 10 power 3, this things get cancelled. So it is 0.8 V2. So VB is equal to 0.8 V2. So we know that VB is equal to VA, so it can also be written as 0.8 V2. So we can substitute this as 0.8 V2, and this is your third equation. And this third equation can be substituted in the second equation. 3 into second equation becomes 11 V2 minus 6 times the 0.8 V2, that is equal to 46.5 into 10 power minus 3. So this 11 V2 minus 4.8 V2, that is equal to 46.5 into 10 power minus 3. So it is 6.2 V2, that is equal to 46.5 into 10 power minus 3, or V2 is equal to 46.5 into 10 power minus 3 divided by 6.2. So this is equal to 7.5 into 10 power minus 3. So V2 is equal to 7.5 millivolts. So we have one voltage source for the differential amplifier. Let's take this as equation number 4. Similarly, we move on to this first equation. So in this equation, instead of VA also we can substitute the value as 0.8 V2. So it is 11 V1 minus 3 times the 0.8 V2, that is equal to 93.18 into 10 power minus 3, right? We have found out this V2 value as 7.5 millivolts, isn't it? That can be substituted in this equation, so that you can write this as 11 V1 minus 3 into 0.8 into 7.5 into 10 power minus 3, since it's millivolts, that is equal to 93.18 into 10 power minus 3. So 11 V1 minus 18 into 10 power minus 3, that is equal to 93.18 into 10 power minus 3. So 11 V1 is equal to 93.18 into 10 power minus 3 plus 18 into 10 power minus 3. So this is equal to 111.18 into 10 power minus 3. So this is 11 V1. So what is V1? V1 is equal to 111.18 into 10 power minus 3 divided by this 11, that gives you 10.10 millivolts. So we got V1 as 10.10 millivolts. So let this be the equation number 5. So we got the voltages at the nodes 1 and 2, that is V1 and V2, which will be acting as the inputs for inverting and the non-inverting terminals. So since this is a differential amplifier, we can find out this output V0 as R2 divided by R1 into V2 minus V1. And this particular equation is applicable whenever you know that this R1 by R2 ratio is equal to R3 by R4. And in our case, this is your R2 and this is your R1 and this is your R3, that is 20 kilo ohm, and this is R4. So we very well know that this ratio is 20 divided by 80 kilo ohms. So it is 1 by 4. So it is equal for both the cases. So that it is simplified as this equation V0 is equal to R2 by R1 into V2 minus V1. Okay, very simple equation we have. In this we can substitute the values. We can find out the answer. V0 is equal to R2 is 80 kilo ohms. So 80 into 10 power 3 divided by 20 into 10 power 3. V2 value we had it as 7.5 millivolts. So it is 10 power minus 3. 10.10 into 10 power minus 3. 10 power minus 3. So this is equal to, this is 4 times, right? 4 times minus 2.6 into 10 power minus 3. So this is equal to minus 10.4 into 10 power minus 3. So what is the output voltage? That is equal to minus 10.4 millivolts.